these are the notes for lesson 5.8, Modeling with Quadratic Functions. In the previous sections in chapter 5, we have been graphing given an equation. In this last section in chapter 5, we're going to do just the reverse of that. We're going to be given the graph of a function, and we are going to find the equation of the function in all three forms. So before we get started, we need to review what each form looks like. The first one is vertex form. If you remember, we find vertex form by completing the square. So y equals a times x minus h quantity squared plus k, where h and k are the vertex and a just tells us how much we are stretching or shrinking our quadratic function. Interceptor root form, remember this shows us our roots or our zeros, and that is y equals a times x minus p times x minus q, where p and q are our roots or our zeros of the function. And standard form is what we see most often, and that's y equals ax squared plus bx plus c. Now, depending on what our graph looks like and what points we can easily see on the graph, that will determine which form we want to start with. For vertex form, if we can easily see where the vertex is, we can start with that one. For intercept form, if we can see where our intercepts are, if they're at integers on our graph, then that would be a good place to start. As far as standard form, the easiest way to get to standard form is by starting from vertex or intercept or root form and just multiplying it through to get to standard form. So looking at the graph, the easiest way to find standard form is just multiplying those other forms out. So if we look at the graph here, we can see that our vertex is up here at the top, and this is 2, 9. You might also notice that our roots are easy to tell on our graph as well. Now, if these are not integers or whole numbers, then we don't want to start with intercept or root form. We only want to start with a form if it's numbers that we know for a fact are those numbers on the graph. So for this point over here, we have the point 5, 0, and our other 0 is -1, 0. So if we start with vertex form, we know what the vertex is. So we can plug in h and k into our equation. So we can plug h and k into our equation. So we get y equals a times x minus 2, that's our vertex in our graph, quantity squared plus 9, because that's our y value. Now what we need to do is find our a. Now the easiest way to do this is find another point on the graph and plug in your x and y values to get your a value. Now we can use any point that's on the graph. We can use the intercepts, or we can use any other point that we can see on the graph. You may also notice that the y-intercept is an easy one to find as well. So that would be 0, 5. We could use that point as well. So you just need to pick a point to use. I'm going to use -1, 0, just because zeros are easy to work with. So I'm going to plug in this for x and y into my equation that I've already created. So y is 0. So I have 0 equals a times x is -1, so -1 minus 2, quantity squared plus 9. So I have 0 equals a times -1 times -2 is -3 squared plus 9. 0 equals -3 times -3 is 9, so this is 9a plus 9. I'm going to subtract 9 from both sides. Again, we're just solving for a. So -9 equals 9a. If we divide by 9, then a equals -1. So to finish up this equation, we're just going to plug in -1 for a. So our final vertex form equation is y equals -1, or just negative, x minus 2 quantity squared plus 9. Next, let's look at intercept or root form. Again, if we look at our graph, we can see exactly where our roots or intercepts are at. They are integers, so they're easy to find. So we can just plug in those values into our equation. So we have y equals a times x minus a -1 times x minus 5. So if we just simplify this, y equals a times x plus 1 times x minus 5 Now we already found A up above, but I also want to show you how to find A in intercept root form. It's the same way. The only thing is for intercept root form, you cannot use the intercepts or roots to find your A value. So you have to pick a different point on your graph. So if we look at our graph, we can see that the y-intercept is 0, 5, so that would be an easy point to use. We could also use the vertex, 2, 9. We could use any of these points on the graph and plug those in to get our A value. So just for something different, I'm going to use our vertex, which is 2, 9. So I'm going to plug in 9 for my y value. So 9 equals A times x is 2, so 2 plus 1 times 2 minus 5. So I get 9 equals A times 3 times negative 3. So I have 9 equals negative 3 times 3 is negative 9. So negative 9A. If I divide by negative 9, I get negative 1. So again, you see that A is the same. So once you've found it for one form, you don't necessarily have to do the work to find it again. So we're just going to plug that back in. So y equals negative x plus 1 times x minus 5. So that is your final equation in intercept or root form. Now, like I said before, standard form, the easiest way to get to standard form is by using intercept or vertex form. So I'm just going to use intercept or root form because it's right above. So I'm going to start with y equals a negative x plus 1 times x minus 5. And we're simply just going to multiply this out. So I'm going to start by foiling or distributing, whichever way you like to think of it as. So x times x is x squared. X times negative 5 is negative 5x. 1 times x is x. And 1 times negative 5 is negative 5. So then we have negative 1 times x squared minus 4x minus 5. And then we're just going to distribute the negative in. So y equals negative x squared plus 4x plus 5. So that's our final standard form answer. So again, each of these equations will get us the same exact graph. It's just 3 different ways of looking at our function. Now again, for example 2, we are finding the equation of this function in all 3 forms, so vertex, intercept or root form, and standard form. Now you may notice when we look at our graph here, we have our vertex here at the bottom, but we can't tell exactly what point our vertex is at. So for vertex form, we're actually going to pass by vertex form for a second, and we're going to come back to that once we've looked at intercept and root form and standard form, because there's a couple different ways that we can get vertex form from intercept, root, and standard form. So if you notice here, we do have our roots or intercepts. So the first one here is 1, 0. And our second root is 4, 0. So if we go down to intercept root form, we can go ahead and plug those into our equation. So we have y equals, we don't know what a is, we're going to look for that in just a second. We have x minus 1 and x minus 4. So again, we can use any point on our graph besides the roots to find our a value. So let's go back up to our graph for a second and see what other points we have. So I want you to take a second and look at the graph and see what other points we have that we can use to plug into intercept root form to get our a value. You may notice on the graph there's 2 points that we could use. The first one here is 2, negative 6. We also have the point that is the mirror image of that, and that is 3, negative 6. So we can use either one of those points to find our a value in our intercept root form. So I'm going to use the point 2, negative 6. Again, you could use either of those points. Either one should get you the same a value. So our y value is going to be negative 6. Remember, this is x and this is y. So we have a equals 2 minus 1 and 2 minus 4. So negative 6 equals a times 1 times negative 2. So we get negative 6 equals negative 2a. Divide by negative 2, and a equals positive 3. So our equation in intercepted root form is y equals 3 times x minus 1 times x minus 4. Now once we have intercept root form, remember we can just multiply it out to get to standard form. So I'm just going to rewrite our equation here. We have y equals 3 times x minus 1 times x minus 4. And again, we're just going to multiply this out. So we have x times x. I'm going to leave 3 on the outside for now. So we have x squared minus 4x minus x plus 4. I'm going to simplify what's inside the parentheses, so I get x squared minus 5x plus 4. And then lastly, I'm going to distribute in that 3. So y equals 3x squared minus 15x plus 12 is my equation in standard form. Now that we have intercept root form and standard form, we need to go back up to vertex form. Now we know that from standard form, if we complete the square, we can get to vertex form. So that's one way of solving. The other one is to use x equals negative b over 2a. If you remember when we first looked at standard form, to find our vertex, to find our x value, we do the opposite of b all over 2 times a. So we can use that to get our vertex, and then we can just plug that into our equation. So again, either way would work. If you feel comfortable with completing the square and you want to use that, that's fine. If not, you can use x equals negative b over 2a, and that will get you a vertex to plug into vertex form. So let's go up to the top here. I'm going to show you getting the vertex from standard form. So I'm going to find my x value for our vertex first. So x equals the opposite of b. So our b value is negative 15. So it's going to be positive 15 all over 2 times a, or 2 times 3. So this is 15 over 6, which is 5 halves. So again, that is my x coordinate of my vertex. So then I'm going to plug that into the equation to get my y value. So y equals 3 times 5 halves squared minus 15 times 5 halves plus 12. And what you can do is just plug all that right into your equation with the parentheses, and then you can get your y value from that, and then just change it back into a fraction using the fraction button on your calculator. So y should be negative 27 over 4. So that makes our vertex 5 halves and negative 27 fourths. So then from here, we're just going to plug that into our vertex form. So y equals, we already know that our a value is 3. Again, we found that when we were looking at intercept root form. So instead of refinding that, I'm just going to rewrite it. There's no point in doing extra work. Then our x value is 5 halves, so x minus 5 halves. And again, we're squaring that, minus 27 fourths. So our equation in vertex form is as follows. So given the graph of a function, we can write it in our 3 different forms: vertex form, intercept or root form, and standard form. Depending on what information they give us on the graph, that will determine which form you want to start with. Again, just a reminder, for vertex form, we can either complete the square, or we can use x equals the opposite of b over 2a. And that will get us into our vertex form.